Hi, everyone. We've set up this Being an Engineer podcast as an industry knowledge repository, if you will. We hope it'll be a tool where engineers can learn about and connect with other companies, technologies, people, resources, and opportunities. So make some connections and enjoy the show.
I had a recruiter once call me that was, like, what are you looking for? And I said, I want to be the dumbest guy in the room. I want to be in over my head. And this team, I was Forrest Gump.
Hello and welcome to the Being an Engineer podcast. Today we are speaking with Roland Schwarz, a mechanical engineer who has held several R&D roles and is currently working at a company called Surfaceink, a product design and development consultancy. Roland, thank you so much for being on the show today.
Oh, glad to be here. I'm glad that I'm excited to have a chance to share what I have with the engineering community, and appreciate you inviting me. Thank you.
Absolutely. That's what it's all about, sharing engineering knowledge with the community. We're doing a R&D series here. This is number 2 of 6 that I have planned. So let's start with the typical question that I ask everyone. What made you decide to become an engineer?
Yeah, it just sort of happened, really. I mostly following my nature. It just, I started off really young, working for my dad. A lot of stories out there. I went through a few of your other podcasts. Everybody seems to have a story about their dad, which says a lot about the roots of a lot of engineers. My dad was a research chemist and a prolific inventor, 50-odd patents, and then he had his own company, and I had a chance to start pretty young with him in junior high, working machine shop, building stuff, and then assembling and doing these test lines for melt-blown fibers and that. So I got to start really young with inventing stuff and building stuff. And, like most young people, I think I had dreams of rock stardom and got distracted with that for a bit. And then that didn't pan out. So I joined the Navy and went to nuclear power school and did well enough there to get the attention of the people who were administering the ROTC scholarships, and then I applied and was awarded, and then went to engineering school. Very power heavy. Everything was actually very focused on power plants and keeping ships moving. Eventually, there'd be a civilian career, but I was really focused on that. And then my senior year, I got medically disqualified, and I were like, well, I have a nice life. And so I started my civilian career at that. But I did know, I wanted to invent and I wanted to design. And so I found jobs where I got to design, and got my first real engineering job at Jacobson Textron in Racine, Wisconsin, and making electric versions of gas and diesel hydraulic tractors. Well, I actually even got to start in the advanced design development group right away in my civilian career. So
very cool. Okay. So do you think of yourself as specifically an R&D engineer, or just kind of a general engineer, and what even is the difference between the two?
Yeah, that's a good question, and I'm sure there are some R&D purists that are going to be like that. It would be hard. I've had the title. It's been on my business card in the past, and I am a product design engineer really by stock and trade, but I seem to give off the R&D type vibe, which works out well for me because I get pulled into the fray. I get pulled into the room where cool things are happening and really crazy smart people are trying to do really crazy things, and they seem to want me along for the ride. So I get to I've had many great opportunities to be part of that.
Well, speaking of many great opportunities, what are some of the common challenges that you seem to run into within that R&D framework? Do you see, kind of a trend of the same type of thing popping up over and over?
Well, it's nobody goes in to research things they know about. It's always a cloud. It's always a mass of, well, we don't know what we know. We need to do something different, or we need to learn something, and we're not even sure. We're hoping that the research becomes development. We want it, but it's there's always a problem, and it's not always an obvious, easy solution that can be arrived at. And sometimes the only solution is that you learn something really important that tells you what you can't do.
Yeah, yeah. What if you had to define what R&D engineering is? Like, what would you say? Talking to maybe a young student who is going to school to become an engineer, but hasn't really had exposure to the industry. How do you describe R&D engineering in your opinion?
Oh God. Yeah. You'd think I would have a more ready answer for this. One of the things I said in our exchange is like, amongst the things, another dad's story. My dad wanted to be a concert pianist, and he was fantastic. All the stuff you hear Schroeder play on the Peanuts cartoons, he played from memory and all that.
Well,
I am not a pianist. I am keyboardist, keyboard player. And I feel the same with R&D, because like I've gotten to work with scientists and PhD engineers and help them do these things. So really, I'm a lot more Igor than Frankenstein when it comes to this. But it's R&D. It's finding new things. It's not it's about finding the true nature of something and then hoping to exploit it.
What do you have any examples of that? Like, do you finding the true nature of something? Can you think of maybe a project in the past where you did that and there was some kind of tangible illustration of it?
Oh yeah. One job I had, we were making hospital beds, basically, well, nursing home beds, but and they're beds that go up and down, almost like a lift mechanism, and really, from an engineering perspective, pretty cool. Honest mechanisms. You can solve most of these with basic statics, but the heart of all of these is always these electrical actuators, and they're high. That's key thing with warranty and performance, and they actually do care about speed. It's hard to imagine that you care about the speed of bed, but yes, they do care how fast these things go up and down. And we had a whole lab set up to test and analyze these things. And we broke dozens and dozens and dozens of these things in magnificent, wonderful ways. And we were learning how these things performed. We had, I had one, I think peak knowledge was when the president of one of these actuator companies hushed his engineers up and told them that I did actually they know what I was talking about and they could learn from me. So like we actually were learning more about these products than the people who were making and selling them.
Oh, how interesting.
All in the name of maximizing performance and avoiding bad product one of the things that also goes along with that is that I'm not always that great at the math, but I respect it and I like it. We had multiple mathematical models that were derived from our results. So we could very accurately exploit this new data information that we were getting. If your math is right and your model is right, everything works, then you're off to the races. You can do all kinds of wonderful, crazy, groundbreaking things. And if your math is wrong, that means your ideas are wrong.
That's an interesting insight.
Because math is just a numerical model, and models are based on behavior and phenomena. And your idea of what's actually happening is wrong, then your math isn't going to add up. So that should tell you something too.
So math is, I think, a great tool that most engineers use to one extent or another. What are some other tools that you found to be really useful within that R&D environment?
Yeah, I was listening, to a couple of your podcasts, and a lot of references to sketching, and I'm horrible. If I wasn't really, I'm really good at CAD. That's my stock and trade, and I can whip it out, and I can thrash it about, and very quickly get to places. And I'm not afraid to be sloppy and sketchy, but I can also get really tight and refined. So for me, that's really been my stock and trade when it comes to actually designing and expressing ideas. I envy the sketchers and drawers and sculptors that can, but I am not. But it's worked out for me the other direction as well. And
well, those sketchers probably envy you with your mad 3D CAD skills. I mean, there's a lot you can do in 3D that you just can't see with 2D sketches.
That's true, and there's times where it's like, it's like, what happens when this shape impacts that one? Bam, bam.
Yeah,
and you can actually see how that comes around a lot, especially round versus round B surfaces clashing and intersecting, and it'll happen a lot of times in unexpected ways. And industrial designers like things to look a certain way and feel a certain way, and then like if you take two round things and mash them together, they don't look round when they're done. So you end up actually having to fake things in the long run to make them look right. That happens, but that's a whole other discussion. And I know you've had plenty of ID and development discussions. I know we're not here for that. I don't want to drag you off into those weeds.
That's another episode. Yeah, we'll have to come back to that one. Okay. Any other tools that come to mind that have been particularly useful? Or there's CAD that really just like the primary one that you've used?
Well, my history, I'm very energy centric because of my past training in that. Even before the Navy, with my dad, all of these fiber making machines, there's a lot of heat exchange, a lot of literally hot air blowing all over the place, and it's all energy exchange. I tend to view things in physics and engineering through an energy lens. Energy is the currency of engineering and physics, and so like you can usually like how much does it take to get from here to there? You can usually figure that out, and what that does, especially in the early parts of a venture, is it tells you the ideal. Some mechanical systems, ignoring friction, blah, blah, like, well, yeah, actually that's important because that tells you this is the best you're going to do. You're not doing better than this. So if you need something that's better than the best you could possibly do, well, you already know you got something else to do. So you don't have to waste time with it.
Absolutely. Yeah.
And I loved physics. I ate it up. I kind of a twisted, sick man that way. But it pays off. If whatever your strengths are, just dig into them. And don't be afraid to be real extra nerdy about it. And music, art, your hobbies, if you're into cars, everything contributes to your mindset. Everything can cross-pollinate and inform your intuition. And then if your information is good, if your education, if your self-education, however you want to call that, you culture your intuition so that what's feeding your intuition is going more likely to lead to something that's realistic and possible.
Yeah, and I think a lot of that just comes with doing, right? The act of performing engineering work, and it doesn't have to be within the context of some, very formal project or school or anything like that. Pick a personal project and try and design something and build something, and you probably learn as much or more from the failures as you do from the successes.
Oh yeah, yeah. I remember learning to cook. I'm not a great cook, but I think that's something everyone can relate to. Going from a
Yeah.
recipe and an instructions and a counter full of ingredients to actually like, today I learned my oven reads hotter than it should. Lesson.
Right.
Get cleaning.
Well, let's see. What are a few things that you do often in R&D that you wish could just be way faster, like 10 times faster?
Well, succeed.
That's cheating. You can't give that answer. More granular.
Yeah, and that's just it. And on the flip side of that is fail fast. But fail honestly. I had this was back at Jacobson again, my first engineering job, and I actually left, and I had 3 prototypes on a test stand that were running this new device, and then I quit, and I went I went to Apple after that, as a contractor, but I'm gone, and then I'm talking to one of my coworkers a few weeks later, and I'm like, "Oh, what happened to my stuff?" And then he goes, "Oh, nobody even looked at them. They just ran for weeks until they all broke." Like, well, and I still care. It's my baby.
Yeah.
I was like, "Well, how'd they all break?" Oh, they all had the certain failure on the belt. They all had it, all 3 of them. I'm like, well, that's golden. Like, we had 3 honest failures, because what would happen a lot of times is that sometimes somebody would be like, "Hey, that's off a little bit. Let me adjust that. Let me fix that." It's like, no, you're not the maintenance guy trying to keep it running. These are your lab rats. You're letting them die a natural death and see what happens. You need that to happen. So honest failure is important. You can't, there are some things you have to let them run their course and fail as nature intended them to.
That's a great example. Maybe it's a failure or maybe it's a success. What's one of your proudest accomplishments within the space of R&D?
Oh yeah. I didn't have much of an R&D role, but this was such a great project, and I can talk about it now because they published it. So, like, I don't think NDAs apply to things that were actually published and on national news. It was with Oculus, assigned there actually through Surfaceink, working on a brain control interface, and it's this hexagonal hockey puck sized thing, and it goes on the side of your head and reads the blood flow in your speech motor cortex. And it was initially like thought of as a game controller, that you'd be able, the way the speech motor cortex works is, how, and of course engineers are really good at this, how you're thinking of something but you don't think you should see it yet, but your mouth says it anyways. That's how the speech motor cortex works. Because as soon as you start thinking about what you're going to say, your speech motor cortex starts like manning the pumps. I'm like, okay. So they could actually determine roughly like what types of sounds were going to be formed.
Wow.
And they couldn't tell the difference between no and go, but they could tell the difference between yes and no.
Oh, that's amazing.
It was, and they had maps. I'm doing models of people's heads from scans, because everybody's speech motor cortex, even they're all in different places, and even your own and from left to right can be different.
Fascinating.
Yeah. So there was a lot of like, we're trying to make special helmets to position these things and make them adjustable or get them in the right spot, get them aimed right. But the really cool thing was, I had a recruiter once call me that was, like, what are you looking for? And I said, I want to be the dumbest guy in the room. I want to be in over my head. And this team, I was Forrest Gump. I was like, I don't know a lot about brain motors, Jenny, but I got to be part of it. Just crazy smart people, literal brain scientists, and of course, image recognition people. And I'm surrounded by PhDs or almost PhDs, and I'm an intellectual peasant with my BSME there, but I'm contributing. I'm doing my part, and they were all wonderful people too. Nobody treated me like a peasant. I'll add that. It was a wonderful team to be on. And they were, they had this goal of reading speech patterns. And in the process, well, you can't start digging into the brain like that without learning new things. I mean, they are learning new things about how the brain works. This isn't just an electrical actuator like, oh, I didn't know I could push that. No, this is the brain. They're like learning new things about how the brain works while they're trying to figure out how to get this machine to work.
Wow, what an incredible experience.
And what really struck me about this, from day one, I'm working on this and they're telling me what they're doing. I'm like, this has such huge implications clinically. And with all the stuff I worked on, from lawnmowers, computers, tablets, earbuds, all the consumer toys I've worked on. I'm like, this is the first thing I've ever worked on that might actually make someone's life better. And they actually did that. They took it, and this is where it gets published, is that they took it to UCSF and tried it out, a version of this out on this quadriplegic. He's quadriplegic and nonverbal. I almost imagine like Captain Pike on that episode of Star Trek, where he can just make the light blink, but he could do more than make the light blink. He could actually form words and make rudimentary sentences. So this guy who had been paralyzed and nonverbal and really hopelessly trapped in his body is finally able to communicate.
Unbelievable. Wow.
Yeah, I was just thrilled that something that started off at that level. I was like, wow, they're actually...
I think most of us as engineers, we love solving problems, and that in and of itself is enough. But when we can solve a problem that actually helps someone, that makes someone's life better, it takes it all the way to the next level, right? I think that's just part of us as engineers. We love that. I mean, maybe it's just part of us as humans, right? Knowing that we helped another human.
Oh, yeah. Yeah. And, as I progress and mature in my career, I am a lot more conscientious about the human side of that. And I've never been a cold, unfeeling reptile of an engineer, and most of us are, engineers kind of have a reputation of being awkward and that, but I'm like, really? Because amongst each other, we're fabulously funny and gregarious.
At least we think we are.
Yeah. So yeah. But everything has an outside context and an outside life. We do as individuals, our knowledge takes on a life of its own, and the bodies of knowledge and bodies of work that we do take on a life of their own and progress in their own ways. That's to me the most exciting thing. Engineering is not just numbers and machines and that. And these things do have a life of their own, and they choose their own directions sometimes and go places.
Well, that's a great segue to the next topic I have, which is frustrations and fulfillments. What again, kind of within that framework of R&D, what makes you happiest? What makes you really fulfilled and satisfied? And then conversely, what are some of the big frustrations that you have to deal with?
Yeah, we'll start with the positives. First off, every engineer, I think, gets into it because we like tinkering, with problem solving. It's a drug. I love it. I love sticky problems, weird problems, things that make me cry a little bit when I'm trying to sort them out. I think the best projects involve some crying at some point.
That's a good way to put it.
But it is, we're attracted, we're attracted to the unknown and to the intractable and the unsolvable or potentially unsolvable. I'll show them what's unsolvable. I'll show them. And so I feel very blessed that I'm just like, I get to do what I would do for fun for a living. Okay. I look at, compare that to like when I had aspirations to be a musician. I'm like, well, actually, like, okay, short of the lights and the stage and all the fun stuff, I'm like, I think I'm having more fun doing this. I'm true to my nature, and and it's also rewarding and respected. I'm like, oh, that's a nice comment. So I dig it.
Yeah.
And again, I've been true to my nature, and it's been good to me in return. So I'm very happy about that. The downside, our email exchange. I think you know where I'm going to go with this. Those of us that are familiar with the Princess Bride, the Dread Pirate Roberts, and Wesley's the cabin boy. Good work, Wesley. Good night. I may kill you in the morning.
Classic line.
And there is. I had a boss. I'm not going to name names. He's like, I put R&D on your business card. It means you're target for every budget cut. I'm like, I didn't ask for that.
Thanks, boss.
And on the business side, R&D is. Some organizations value it, and they value the people, and they value the knowledge base, and even if there's not a direct payoff, because the people, business types, imagine some bad 80s movie. He wants his payoff. He wants his thing. Yeah, people want an ROI, and they want a payoff, and long term, just building a knowledge base and building knowledge. Institutional knowledge has a value that you can't just put a number to it, but if you don't have it, it's that number is zero and you get nothing from it. And you're kind of at the whims of the feelings, the zeitgeist of the organization you're in. If they value R&D, you're golden. Well, you're good to go. But a lot of places you're kind of on shaky ground, or we don't know how much we want to sink into this. We don't know how valuable it is. And the other aspect is that you can write all the papers you want, catalog all you want, library all you want. But when it comes down to it, the knowledge is contained in people. And that makes them nervous too, I think. It's hard because like your knowledge can walk out the door and take it somewhere else. That's I think frightens a lot of that. That's a specter that haunts a lot of businesses, I think.
I can speak to that. I mean, from the other side, right? As a business owner, that's probably the thing that I fear the most is good engineers leaving. For whatever the reason, could be a completely innocuous reason, but that knowledge and that capability, walking out the door and going somewhere else, and then having to replace it somehow, that is a scary thought for sure.
Yeah, I don't envy people who are on the fixing side of that dilemma either.
Yeah. Well, people do leave on occasion, and new people have to be either recruited or trained. What do you think are one or two of the most difficult things about teaching someone to become an R&D engineer?
Yeah, well, one of the things, God, I hope I'm not giving away a trade secret here. But we at Surfaceink, one of the things we look for is innate curiosity. Are you an intellectually curious person? And I've gotten to do interviews. It's not a question you ask outright. You kind of get people talking, and when you see what they're excited about and what excites them about it, and you can see if there are people who are, it doesn't matter if they're into horses or into cars, or if they're into making their lawn the best lawn it can be. If they're obsessed with something, that means they're also deep divers. And, I'll put modesty aside enough to say I'm an expert in CAD. I have established a good track record of being able to make CAD do crazy stuff and being able to make it hold together, this, that. I know what it's like to be an expert in something. And I can appreciate it when you hear that expertise vibe come from someone else. If you've achieved expertise in something, dare I say mastery even, master is always still a student, blah, blah, blah. But if you've achieved mastery in something, you know what mastery looks like. You know what it sounds like. You know what it feels like. And when you see it in somebody else and what they're doing, then you're like, okay, they've done the deep dives and they've done the long stretches, and they know what it's like and how far and how deep you have to go to master something. So I think that's, without putting degree initials after somebody, I would say that would be the trait that I would want to see.
Curiosity. Any other mindsets or attributes that come to mind that really set apart a good R&D engineer from a mediocre one?
Yeah, I wish there was a clever word for it, but like I said about failing honestly, but is it a failure? New knowledge, all accurate knowledge, all true knowledge is good knowledge. If you've dispelled a myth, a treasured myth of some sort, that's good. You've aligned closer to nature and to the truth. And some people are more keen and aligned to do that. Some are more prone to that than others. There's engineers, and I'll bet 201, every engineer I've ever met, worked with, talked to, we all think the same. Your idea should stand on its own. Every idea has merit. It should sell itself. Oh God, I wish that was true. I do, because we would have a better world if that was true. No, dumb ideas are better salesmen half the time. I don't know. When you know something is right and true, and you're as introverted as I am, as most of us are, you still need to learn and find the courage to stand on truths and what you do. And it's also important to learn to articulate it. And I dare say, and I'm guilty of being on the wrong side of this one, do it without alienating people and making them,
Well said. Well said. All right. Well, let's see. Just maybe one or two more questions here, and we'll wrap things up. Let's pretend that it's 3 years from now, and you're looking back, reflecting over the last 3 years. What has to be true for you to feel happy and fulfilled in your role as an R&D engineer?
Well, more of the same. I love what I'm doing. And I never made a huge effort to climb up in the management ranks. That's why I didn't actually go to grad school. My dad and even some of my advisor, and when I was in college, he's like, no, I had a chance to start up that chain. And he's like, don't do it. I know what you want to do. And this is not the path for you to be on this. Now, maybe it would have helped somewhere along the way. And I am not going to knock the guys who've gone all the way. That's a different level altogether. And I have a lot of respect for it deeply. So I want to do more of the same, but I've also recently been elevated to sort of a team leader. I'm in the care, administratively, at least, taking care of some of our Surfaceink employees and making sure that they are well taken care of. And it's a new frontier for me. I'm really looking forward to the opportunity to help my fellow engineers have a better career in our organization, because I love Surfaceink, because I didn't really go into the details on my Surfaceink story, but my roots with that company, I started with them officially in 2015, but my roots with them go back to the founding. I was friends with Jeremy Akel and Eric Boswell before they even founded Surfaceink. And a lot of our friends from Wisconsin worked there at different times as well. And it is very much a home. And when Eric brought me on, it was like, he knew what he was hiring when he got me, So I I am very excited to be part of the process of making this what I believe it should be for our fellow engineers that work for us. And my grandfather on my mom's side was an artillery officer in the German army during the war. And my uncle told me the story. He's like, do you miss the army? And he says, I miss taking care of my men. And that's where his focus was. And that's where, he certainly didn't miss combat. He didn't miss privation and starvation and all that, but he missed taking care of people. And I think from years and years of kind of just be hyper independent and that to reaching out and helping to build a community that's the big frontier for me right now.
I think that there is a lot of truth to that, especially as we get older. I've noticed that myself as well, that engineers, we always have this thirst for knowledge and we want to learn new things, and that's fun and exciting for us. And maybe during our younger years, learning the new technical things is where we're most focused. And as we get older, we start having these opportunities, maybe because we've achieved some level of expertise or mastery at these technical things, and we start having the opportunity to learn about taking care of people and building communities. And that does become a very rewarding and exciting new opportunity for us to explore. So well said, for sure. All right. Well, Roland, I sure appreciate you sharing your experiences and your insights with us here on the show. How can people get in touch with you?
Well, LinkedIn's the easiest place. I respond readily to LinkedIn. If you Google LinkedIn, search my name and Surfaceink on LinkedIn, I'll come right up.
Excellent.
And I love my LinkedIn community.
Perfect.
I sound like a commercial for them. No, I'm not affiliated. Okay.
All right. Well, Roland, thank you again so much. I sure appreciate you being on the show today.
Well, thank you, Aaron. It was a privilege. I'm honored that I got your attention and merited the invitation. So thank you.
Absolutely. I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.